So my name is Matt, and my handle is spelled S-Y-K-E, and I'm a member of New Hack City, which is a hacker collective in San Francisco. And Jeru, he's right here, he's also going to attempt to speak, hopefully with a video projector in place of some kind. What else can I say? So I worked for 2 years for a commercial vendor of security software. It doesn't really matter which one, and I prefer not to say because I'd hate to think that people think their products are better because of my knowledge anyway. We have t-shirts for sale out there, and I'm going to be giving out t-shirts. New Hack has already sold out before anyone even knew who they really were. We figured we just jumped the gun. I think the inspiration was AdStake selling out so fast, or Loft selling out to AdStake so fast. So here's the basic deal, is that there's four major areas I'm going to cover, and I posted an outline Jeff posted my outline to the DefCon webpage, and I've changed it a little bit since then because I thought it'd be a little bit more interesting to look at things from a bit more holistic perspective. So I'm going to cover 4 areas, and those 4 areas are what user expectations of IDSes and firewalls are, like why do people buy these things in the first place? And then the second thing is how to test for those expectations to make sure that people are getting what they want, hypothetically. And then the third section is common coding problems that sort of come up, that sort of bubble to the surface when you actually start doing this kind of testing. And then the fourth thing is what designers and people who are writing these things, like right now, like from scratch, can do to avoid a lot of the mistakes that I have seen in the last couple of years, code-wise and design-wise. So the first thing is users. Why do people buy IDSes and firewalls? And like, why is that such a popular market right now? In like the last year, it's up to a couple $1 billion or something. It's like crazy that people are actually paying money for this stuff. Well, I think the main reason is people basically don't care. Users really don't care if a proxy firewall or a packet filtering based firewall or a hybrid firewall is going to make them more safe, or if a network-based IDS or a host-based IDS is going to make them more safe. All that they care about is they have a topology and an infrastructure they don't want to change, and they will put in whatever is going to fit in what they have right now. Whatever is the easiest thing to implement is what they're going to end up implementing. And that's basically what it comes down to. So this talk has nothing to do with arguing over which is better or any of this complete nonsense. Because you have to make both, because people want both or need both or have been convinced that they want or need both kinds in either the firewall or the IDS space. So yeah, people just want to deploy and not have to deal with anything. I think most people actually are aware that IDSes don't make you safe. I'm pretty confident of this. A lot of people think, a lot of, hacksaws and like security consultants or whatever, think that like general, I don't know if you call them consumers or not, think that IDSes make you more safe somehow. IDSes just give you time to react, and that's all that they do. And I think that most people are aware of this. I think that most people don't think that IDSes are going to magically stop you from being attacked. So I don't think that there's a misperception there. Firewalls, this is kind of weird, because real purists will say, firewalls and IDSes are fluff and crap, and they just need to fix the real problems and like make the code in the OSs better and in the FTP daemons and whatever. That's not really practical. So from a certain standpoint, firewalls do help you reduce and manage risk, right? If the firewalls are implemented properly in both code and topology, right? If the coding is solid, like they've done everything properly, and you've deployed it properly in your infrastructure, and you've configured it properly and everything, hypothetically speaking, it will reduce like the ways people can get in. hypothetically. Although we've all seen like the hacking exposed things that Ernst & Young and those guys did, where like they don't need, all they need is port 80, and then they bounce in and do a port 139 redirect and using netcat and like all kinds of crazy shit. So, but hypothetically, from a certain perspective, it does reduce risk. And so vendors have convinced people, of course, that since some bullshit percent number, let's say 80% of all intrusions come internally, and your firewall isn't going to protect you from those, you need to have an IDS anyway. So you need to have your IDS to protect you from the outside problems, and you need an IDS to protect you from the problems that the firewall can't block or you just can't deal with or whatever. Okay, so people expect firewalls to keep packets out, and people expect IDSes to tell them when they're being attacked with whatever signatures. Oh my God, is that a video projector? Be still my heart. So this is what people are expecting. So section 2, how do you test for these expectations? I have 3 favorite tools, basically. They are Nmap, Whisker, and Ipsec. And Ipsec is a suite of utilities. And I think Mike Franson, who Ipsec is here, he's right there. This guy is the bomb shit right here. This guy's tools have helped me find so many bugs. We released NewHack released a NetBSD advisory 2 months ago or something. Yes, you do get a t-shirt. I promise. Here's a t-shirt. Oh, by the way, here's what they look like. ASCII art. You can see the logo at the bottom. Let me see if I can throw it that far, right? Pretty close. There you go. Yeah, so Nmap, Whisker, and Ipsec. Basically, here's the deal. You can't just download these tools and start using them and like think you're going to find shit. Please understand what these tools are doing. Like, even if you can't read code, read the docs and like figure it out. Like, I don't think I'm that smart, and yet like I can like sort of like know how this stuff works. And if you actually read the docs and understand how it works, you'll understand that when you're using Ipsec or Syke, that you should disconnect yourself from like public networks so that you don't like DOS every box on like the subnet plus, which people still do. Yes? ISIC, oh I'm sorry, it's IP Stack Integrity Checker. And it's actually a suite of utilities. And I'm going to go through each of them individually and how they should be used. And I'll say the URLs at the end. It's really pathetic. I have all these URLs memorized. So, understand the tools. Okay. What the fuck is that? That's odd. Okay. What do the tools do? I'm glad you asked. I think everyone knows what Nmap is. I think it's pretty ridiculous how popular Nmap is and how much everyone uses it for everything, and how every time you go on an IRC channel someone says, "You're running NetBSD!" And it's like, well, that's great. Thanks for telling me something I didn't know. So Nmap is really good, not as a port scan or anything like that. Nmap is really cool for testing a couple of things in firewalls and IDSes. In state-based packet filtering firewalls and NAT implementations, and even Ipsec tunnel implementations, Nmap is really, it's so simple, it's really elegant. Just like doing a port scan through like a trusted tunnel, like a fin scan or something, and then, you know, watch like the Ipsec implementation and then like take a shit. All these tools, by the way, are like the focus is firewalls and IDSes, but testing Ipsec tunnels, like if you go to your VPN bake-offs in like your area or whatever, take these tools with you. Whisker not so much, but like Ipsec especially, holy shit. Ipsec found so many things, so many bugs in Ipsec implementations, it's not even funny. So anyway, Nmap. So just doing a simple port scan with Nmap will usually suffice. So because I don't have my slides and my pretty pictures, I'm going to use my hands So I have an untrusted network, the big bad internet over here. I have my firewall, IDS, whatever the fuck. And then I have my trusted machines that are protected by the firewall and whatever else. So an interesting thing to do is to run an Nmap scan through all 65,535 ports, just to really give the state table. Should I explain this? So in an IDS, when you make a connection, when you send a SYN, there's a state table structure generally. I don't know if everyone's implemented this the same way, but I don't know how else you do it. There's a state table structure, then it adds your source and the destination like this. Yes? Oh my goodness. All right. Where is that at? Right here? Awesome. Oh. What? Do you actually expect me to use star office? Yeah. Whatever. Introduction, rundown, user expectations, testing for blah. Most users are aware. We should have both anyway. Nmap whisker. Oh, I'm sorry. So I'll start here. So here's this. So Nmap whisker, Ipsec internal checker. Don't just use these tools blindly. Understand how the fuck they work. Otherwise, your testing means dick, and you post a security focus like an idiot, or post a bug track like an idiot. I ran Nmap 1,000 times, and then when I came back in the morning, the box crashed. That doesn't help anybody. It really doesn't. The vendor's well, what was your configuration? It's I wiped the box already. You really aren't helping anybody trying to solve the problem that you've found. Configuration can make a difference, especially on firewalls. Let's say that you do an Nmap test, or you run TCP/SYK, route it through the firewall, and you have one deny rule. I've seen situations where you add an allow rule, or you add an absorb rule, or whatever, or you add 2 deny rules or something, and then the machine will crash, or then it'll leak packets, or what have you. So if you're really interested in finding problems and stuff, just be really diligent if you have the time and the resources and whatever. Oh yeah, so here's the network idea. Untrusted, you have your target machine, which is your firewall, and then you have your trusted network. And so usually in my examples I say go from untrusted to trusted, because that's usually what people do when they're doing penetration testing. But if you're looking for crashes or packet leakage or whatever, you can find it the other way as well. And people usually miss this. I found a couple of bugs in the software I was testing by just going the other way around, especially with NAT. If you have a NATed firewall, or IP masqueraded, or whatever links people call it, and you send the other way you send from trusted to untrusted instead of the other way around, that gives the code that maintains the state tables for NAT a really good workout. I'll give you an example of a bug that I found that worked like that. When you sent FIN packets through NAT from trusted to untrusted, the firewall made an entry in the state table for that FIN, and then never removed it, ever. So if you did a FIN scan or flooded it with FINs or what have you, from random source addresses, basically you're testing to see if there's any unchecked mallocs. And if there's an unchecked malloc, and usually the stuff is in ring 0, you've got a blue screen or an oops, or whatever Linux calls it, or a kernel panic or what have you. Huh?
Whose firewall?
Whose firewall's what?
Whose firewall?
It doesn't matter, it's been fixed. Next, right. Okay, so Nmap. Yeah, state table code and packet filter and NAT implementations. From an untrusted machine, netmap, Nmap, SYN-scan, ports 1 through 65,535. A really cool thing to do, by the way, that Nmap won't let you do is send stuff from port 0 through a firewall. That gets interesting results sometimes. Same way with an Ipsec tunnel, et cetera, et cetera. And so what you can see when you do this, if you know how to look, by the way, if anyone knows how to see non-paged kernel memory usage in Linux, could you please tell me, either programmatically or otherwise, because I couldn't find any information on the net at all on how to do it. But if you were able to do that, like you are on NT in about 1 second, what you'd see is that when you do that, you see non-page kernel memory increase because what's happening is the state table is growing because you're doing like a lot of connections. And so, like I said, what this tests for is one unchecked malloc. Like most operating systems impose a hard limit on non-page kernel memory, like 16 meg or 20 meg or however much it is. I think it depends on how much physical RAM you have. For you non-OS architecture people, non-page kernel memory is non-page kernel memory is memory only accessible to the kernel that never gets paged out, ever, because for whatever reason the data structure that's holding it couldn't handle like a virtual memory fault or a page fault of any kind. And state tables happen to fall into this sort of category. And so if you make the state table go large enough, eventually it's going to hit that hard limit of non-page kernel memory. The OS is going to say sorry, right? And I've seen it time and time and time again, where I don't know why, but people don't check the return values of syscalls. Not just malloc, although malloc is like the most common, or in all the other alloc calls as well. There's been a couple vulnerabilities now, like people weren't checking the return of set GID, like if that failed and like defaulted to 0 or something. I think there's a rule or something. It's the Afro Pic show. So that's basically what you're testing. And if you're looking for stuff like that, like you're like looking for DOSs where they run out of memory and then they fuck up because they didn't check a malloc somewhere, both in Linux and in NT, and probably BSD as well, you can limit the amount of physical memory the OS will use. That will help you greatly in finding these bugs faster, because if you're doing this on a 128 meg machine, you really have to beat the living fuck out of it in order to like get it to crash or do whatever you're trying to get it to do. And so if you just kind of lower it just a little bit, you'll hit these conditions a lot easier. Wait, I don't want to go Whisker. What the fuck? Go back to there we go. Different scan types, like I said, fin packet and a certain implementation of stateful packet filter firewall. Didn't remove fins if you just sent a fin. It was really odd. I don't know how the thing ever worked. It probably didn't ever work. But ACK scans, et cetera, et cetera. So tiny IP frags. This used to be an interesting way to leak packets through firewalls and to make firewalls crash, because for stateful packet filter-based firewall, god damn it, it's hot. Wow. For a stateful packet filter to do its job properly, if I've blocked port 80, I'm going to assume some knowledge of TCP IP here. If I block port 80 and the TCP header is split up across multiple IP packets, right? So when I get my first IP packet on the firewall and I'm analyzing it and I'm looking at it, and I'll say, okay, is this allowed on the ports that I'm allowing to pass through me? Well, I can't see the port because that port information in the TCP header is in the next IP fragment. You can do one of two things if you're an implementer. You can either reassemble it to get the full TCP header, in which case you're opening yourself to DOSs with memory usage, with people sending a whole lot of frags and you're holding them waiting for the next fragment to come so you can get the full header. Or you can just drop them. I'd recommend dropping them because the likelihood that an MTU is that small that a TCP header would be split across IP packets is very, 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 very unlikely. In fact, if anyone can tell me a configuration in which that would really happen, I'd really like to hear it. So if you're an implementer, drop tiny IP frags. Don't even fuck with them. It's not even worth any trouble, because it doesn't happen in real life. If someone sends you tiny IP frags, they're fucking with you, period. So the neat thing tiny IP frags does now is that state-based IDSes that keep track of connections and whatever else, if your IDS is like a logic tree, like they're not just doing flat sort of packet grepping, and they actually check to see that, okay, there's a SYN, all right, there's an ACK, okay, and then I look for my get PHF, right? Stuff like, IDSes that do stuff like that are actually, this sort of stuff kind of works, because for IDSes that don't do IP fragmentation reassembly, it has the same problem that the state-based packet filtering firewalls do, in that they can't get the full state with the first packet. So it's like, what do? I can't do reassembly either, so I guess I'm just not going to pay attention to this stream unless it matches like my packet gripping. And because you're fragmenting that small anyway, it doesn't really matter. And you can do tiny IP frags with another tool that I almost mentioned called Frag Router. And Frag Router is a fine tool. I think it's written by Doug Song. Maybe he's here. That can send tiny IP frags with just regular traffic. It works just like it sounds. It's a router that fragments packets to whatever interesting configuration you want. So, SynScan port 1, like all the ports basically, doing a full port sweep, expands and contracts state tables if they're implemented properly. So this is pretty evil because this next example here, nmap, synscan, all the ports, decoy scan. I love decoy scan. Let me tell you why I love decoy scan. And with decoy scan, you can fill up state tables faster than anything. And I really like using really fucked up addresses for the decoy scan, which if you're 1 or 2 hops away, you could probably get away with, but it might not be practical. So if we, can I go back one? So see here, this network here is 192.168.2, and the one I'm sending from is 10.0.0. Can you go back again? Forward one. Huh? Oh, thanks. Does it work? No? This thing here? Yeah. So I'm using the loopback address of the destination network, the broadcast address of the destination network, and then the loopback and the broadcast of my network, and then just crazy shit like, 255.255.255.255 and 0.0.0.0. I've found interesting packet leakage problems doing stuff like this. Whether or not these packets can be routed through the actual internet is a whole other question. But if someone owns your ISP and they're 1 hop away, it's a completely feasible scenario. So decoy scans are actually pretty neat, and actually I don't think that they're really useful for evading IDS detection at all, because that's what the original purpose was that you do so many parallel scans that the IDS logs flood and they can't tell what's going on because they see so many source addresses for the port scans, and they can't tell which one's the real one. And so nmap can be gotten from http://insecure.org/nmap, insecure.org/nmap. I think everyone knows that. Whoever doesn't know that shouldn't be here. Next. Please. Next, please. Thank you. Whisker. Whisker is really cool. It's written in Perl, so you can just run it on Win32 or Linux or BSD or whatever the fuck runs Perl. Probably your Palm Pilot can run Whisker if it runs Perl. Yes, sir? I'm sorry. All right. That would be nice. Do what? Turn up the volume? Like this? All right. So, I think everyone knows what Whisker is basically made to, is a HTTP scanner, but Rainforest Puppy, bless his heart, add a whole bunch of IDS evasion functionality, which is really cool. If you see him, give him a big hug and a smooch, because he really deserves it. Because this gets past, these things, I think, I have not seen a firewall, or I haven't seen an IDS that one of those evasion techniques does not get past. If you can show me one, I'll blow you or something. So, Whisker basically what? Oh, thank you. Let me take a drink real quick. So Whisker works like this. You have Perl installed. You have Perl installed. It's just whisker-h, your target host, and then -i goes through all of the various IDS evasion techniques. -i1 is URL encoding, which is a very popular one to do, which, what's his face, Robert Grant from Network Ice blasted Network Associates' CyberCop monitor for not doing when it really does. So I think everyone knows like Whisker is good for doing this stuff, but here's the interesting point that I don't think anybody has thought of is HTTP proxies are blocked by URL, like they block, like anything where fuck is in the URL or something. How much do you want to bet that they're all susceptible to URL encoding? I bet you that they all are. So a lot of people think proxies are just deployed so that users on the inside can browse the web through this proxy. Well, actually, sometimes it works the other way around. We'll have a proxy so that people coming in from the outside, like, are limited access unless they belong to certain URLs, unless they belong to a certain IP range or something like that, or they authenticate first. This gets past that. Something else to test for in HTTP proxies. I'm not going to talk too much about this because Whisker has great docs. Everyone knows what the hell it is and knows what it does and knows what its capabilities are. So the URL is http://www.wiretrip.net/RFP. You can go in there and choose your theme and then find the Whisker docs. That's www.wiretrip.net/RFP for Rainforest Puppy. Next. Syke, okay. I'm sorry, I can't get over it. These are my favorite tools ever for testing this kind of stuff. It's not necessarily a new idea, it's just somebody finally did it. Syke is a suite of utilities. There's Syke, which is IP Stack Integrity Checker. TCP Syke is TCP Stack Integrity Checker. UDP is UDP, and ICMP is ICP. And eSyk is Ethernet, which is actually really cool. We found some interesting problems with that that we'll probably release sometime in the next millennia, hopefully. Great for testing protocol implementations on all of these. Like I said, we found the NetBSD bug, the remote crash, with an ICMP packet using, it wasn't an ICMP packet, it was unaligned IP options, caused an unaligned memory access using, it stopped working. There it goes. Using ICMP Syke, and the steps were to reproduce from the advisory. Syke, all the utilities are use libnet by route, which is also a great library. Beautiful code to read if you're into that kind of thing. State-based IDSes and packet filters. Wow. Basically what these tools do is they send sort of controlled random packets. It's kind of interesting. So basically you seed it with a random seed. Remember in all your basic stuff, we would use rand and you have to seed it with like 32K to negative 32K? Works kind of like that. And so basically if you enter the same random seed, you'll get the same random results. And it does IP options, it changes all the IP options, it changes the length, changes the header length, lies about the header length, all kinds of crazy shit. Basically it throws a lot, it just pukes all over the protocol stack and sees if the protocol stack can take it. Because state-based IDSes and packet folders are sort of kind of implementations of TCP/IP to an extent. God, it's hot. Our implementation of TCP/IP to an extent, this sort of vomiting works as well, and it's just like Nmap with the state-based IDS, where from a certain IP I go a state-based IDS, I go SYN, and then wait a minute, I don't get an ACK, I get a FIN immediately, and oh god, I'm screwed and I puke. Same way with state-based firewalls, small IP packets, not necessarily tiny IP frags, certain fragment offsets. That's what else this is good at finding, is some things are sensitive to just certain fragment offsets. And if you run these tools for long enough, eventually you'll hit all of them. Ipsec Tunnels, same thing. In fact, I would if someone would take these, Hugh Daniel and I talked about this a couple months ago. I don't know if he's done it yet, but he used to take hping, some utility called hping, to VPN bake-offs and try and get other people's IPsec limitations to crash at the bake-offs. And I pointed up an Isaac, and I don't know if he's actually used it yet. I really hope he does, because I'm sure that it'll just make a whole lot of people's IPsec implementations just puke. And NAT as well. NAT once again. Testing from both, routing from both, the trusted network to untrusted and untrusted to trusted and everything in between. Also firing directly at the untrusted interface of the firewall and at the trusted interface of the firewall as well can yield some different results. And also before, like I said, try all kinds of different configurations, one with a deny, one with an allow, two denies, two allows, and absorb, whatever. So here's the example. TCP/SIC-S, which is specifies the source IP, RAND. If you specify RAND, it will pick a random IP for every single packet it sends out. It's pretty cool. Sometimes, though, you don't want to do that because the firewall will just drop things that, like if you're testing from the trusted network to an untrusted network, for instance. I'll do questions at the end. If you're testing from the trusted network to an untrusted network, and you aren't sending from the subnet of the untrusted network, the firewall will be smart enough to just drop your packet, and you won't go all the way through the code paths that you need to test them properly. So -srand is a good way to do things. When you use -srand, unplug yourself from the public internet. All right? When you send packets at a host, it's going to reply back to the source address, right? And if you hit some .mil by accident or something, and people come knocking on your door, that's why, all right? Especially when you're using ESIC, because ESIC by default sends to the broadcast Ethernet address. It kills networks, okay? If you can, if you can hide a laptop somewhere running ESIC that's broadcasting, that's sending like Ethernet frames to the broadcast address, you will kill a network. That's not really legitimate testing, though. That's just an aside. And then -D is the destination, trusted, so if we're going from untrusted. And be sure to set your random seed. If you don't set it, it uses the process ID of what it's running as right now. And so when you don't use -R, like your PID is incremental or random in OpenBSD or whatever, you won't get consistent results. And I've seen this mistake happen with people who didn't understand the tool, basically. They just, they did -srand, -D trusted, and then they just went to town. And then, they got something to crash. And then they could never get it to crash again. I'm like, well, what was your random seed? I don't know. Well. So I usually use 31337 or 666, something that's really dumb and easy to remember. If you can't get, anything to happen in, the first 5 million packets or so, try changing the random seed to something else. -M700 limits, it's like the maximum amount of packets you can pump out on the network, kilobytes per second wise. Now, like the next point says, Linux sends packets fucking fast, like 4 meg per second, really fast. But, as we mentioned in our NetBSD advisory, Linux mangles packets and doesn't tell you. And so when we were doing some last-minute testing to make sure this was completely reproducible before we released the advisory, we couldn't reproduce it on Linux, and we were like, what the fuck is going on? And so we tested it from BSD. It worked. Problem with BSD is that because for whatever architectural reason, it's a lot slower at sending packets. It has these things called NMB clusters that fill up very fast for whatever reason. So you can't send them as fast. If you send them as fast, it will drop packets. So instead of sending mangled packets, you just don't send the packets at all. And this can be a problem. So -M700, when we were sending from some ARM32 boxes running NetBSD, and also from OpenBSD on some Pentium 2s or something, that seemed to be about right. And I don't think it has anything to do with how fast the machine is. I think it has to do with the drivers and how they were written. And if you run into that, if your machine's slow or whatever, you can increase NMB clusters. Don't ask me how. I don't know anything about Unix. So the URL for ISIC, the suite of utilities, is http://expert.cc.purdue.edu/FRANTZEN, that man's last name right there. So expert.cc.purdue.edu/tilde-francis. So that's slide 8. Next, please. I was going to have a code example, by the way, but it's got lost in the ether, so I can't do it. Okay, so this is only loosely related, but as far as like the point of this is like this kind of testing like brings about certain problems with memory allocation, not checking syscalls, not checking return values of the return values of syscalls, various other problems. So just some suggestions for dev managers, for whatever else. For the love of Christ, don't just start coding if you're going to do something serious. Right? If you're going to write like a 200-line program, fine. Like get stoned, drunk, and like code until your fingers bleed. But if you're going to do something serious, define your interfaces first. Plan first. Try and maintain consistency in the interfaces. God, it drives me crazy. I really, really hate code that's just a total rat's nest. There's no consistency at all. So this is always a good idea. And if you're in a professional environment, modeling tools like UML, what else, Aaron? UML, like rational rows, whatever, can maybe help you if you're into that kind of thing. Writing clean, well-documented code, I mean like well-formatted, like you can read it, good comments, stuff like that, will save you time and aneurysms later. A lot of people think it's a waste of time. A lot of managers think, no, we don't have time to clean it up, whatever. It will always bite you in the ass, every single time. When you think the code is going to be used for 3 months and you're going to rewrite it, it's going to last 3 years, every single time. Have never seen it not happen. All right, this is a real pet peeve. All right, anybody try to compile Nmap like 2.08 or like Nmap anything pre-2.5, and there's a zillion warnings complaining about all kinds of crazy shit, and most of it ended up being bugs. Linux, GNU, not so much BSD, like GNU programs just all the time, where like the compiler gives you warnings for a reason. Okay? It's not telling you just for like, to fill up your screen with crap. Please fix warnings if you see them. It's like the most simple thing that's overlooked every single time. Another thing is source and runtime analysis tools. If you have the loads and loads of cache to spend on Purify and Ensure++ and Flexilent and stuff like that. If anyone wants to talk to me further about this stuff, I can talk about it at great length, but it's nothing to do with next. Code was supposed to be here. No, go back. I will embellish my lameness for a minute. Code was supposed to be here, and I was going to like ask the crowd for to tell me what was wrong with it. And so I'll put it up on the NewHack page, or off my page off of NewHack, and along with these slides, and hopefully a recording of the talk. And y'all can send me mail saying like what you see, be like, where's Waldo of lame coding. So what I was going to do was, for every guess someone got right of what was wrong, I was going to hand out a shirt. So I'm going to hand out shirts during the Q&A instead for people who have really good questions. Next. For designers, and coders, if you're implementing on NT and you're interested in application level stuff, use TDI. Transport something interface. I can't remember what it is. Transport data? Transport driver interface, thank you. You get stuff pre-IP assembled. So you don't have to duplicate work of the IP stack and further slow your IDS down. However, this only works on host-based IDSes, which could be argued with the IDSes that really work. But and it works on Windows 9, Windows 95, 98, whatever, NT, and Win2K. So if you write code, it's going to be portable for the most part. The other thing you can use, I didn't mention here on the slide, is IP helper functionality is kind of interesting. Instead of like maintaining your own state table, just use the OSs. In Windows 98 and NT starting with Service Pack 4, NT 4.0 starting with Service Pack 4. there's these IP helper functions where you can actually get the connection table. You can see who's connected and not have to deal with maintaining your own state and duplicating more work. And if you do this, you're just going to be faster, and you're just not duplicating work. So because you're not duplicating code, you're not going to like implement mistakes all over again, et cetera, et cetera. And in Linux 2.4, you can use netfilter interfaces, like the Linux kernel actually has proper interfaces for something, if you can fathom such a thing. You can use the netfilter interfaces to wedge yourself at whatever point in the stack you want to get data, much like TDI/NDIS on Windows. And this is what I highly recommend. I wouldn't bother re-implementing IP flag reassembly, TCP stream reassembly. It's just dumb, okay? Seriously, okay? Because when you re-implement things, there's the other thing. Don't re-implement things, okay? Don't rewrite libc calls. It's stupid. All right? When you write code, you're going to make mistakes. When you rewrite code that's existed for 10 to 15 plus years, right? It's been around for that long. People have probably found a lot of the bugs, right? People aren't going to find the bugs that are in your shitty code. Don't rewrite libc calls. If someone can argue with me later and prove me wrong on this, great. I'd really like to be proven wrong. Right now, it just annoys the shit out of me that things take 3 times as long just because someone has to rewrite SNPrintf. Oh, and also, when you're doing NAT and IP stack stuff, use the free stuff. There's no reason not to. Try and find someone else who has a NAT implementation like Cisco. Like everyone in the world used Cisco's first like basic reference implementation of IPsec and Ipsec and that's why they're all vulnerable to UDP garbage appendage bugs. But if it's mature code and you're reusing it, that's a good thing. You aren't wasting time. It's a really good thing. I can't stress this enough. If you have to argue with your manager about it, tell them send me mail. I'll gladly argue. This is something I love arguing about. So there's a New Hack City webpage, www.newhackcity.net. There is not a whole heck of a lot there right now, but I'm sure there will be in the future. We'll be able to buy various memorabilia, bongs, etc. And that's my email address, syke@newhackcity.net, NEWHACKSCYTY.net. And that's it. So Q&A.
If you're running Isaac and it sends like 5 million packets at your IDS and one of them crashes it, how do you narrow down which one did it?
Excellent question. Excellent question. There's something I overlooked and I forgot to add in. Isaac has 2 options, -P, which says send this many packets, and -K, which says skip this many packets. Mike should really be doing a talk on Isaac at this con. And so what you do is if you don't let it run overnight. Like try and pay attention, like look every 500,000 packets or something and see if it crashes. Jeru actually wrote a patch that pinged after every so many packets. And I think, maybe it was Mike told me someone like wrote a shell script or something that would send X number of packets, ping the host, and then like, sort of incrementally go. Huh? Okay. He says there's one included in the tarball. So if you go to the webpage, expert.cc.purdue.edu/tilde, FRANTZEN, it's in the tarball. But to answer your question so that you understand what's going on. So what you do is it crashed sometime between packets 2.5 million and 3 million, sake of argument. So what you do is you do Isaac -S whatever, -D whatever, -R whatever, and then you do -P for sending, and you say -P send 3 million packets, and you say -K skip the first 2.5 million. When it skips packets, it takes a really long time because it has to go through with the random thing so you get the same results if you use the same random seed. And then from there you just do binary search. If it crashes again, just say, fucking A, it's reproducible. Otherwise, you expand your search a bit. And so once you have the range, you know the range, just start doing the binary search. And you say, okay, it's between 2.5 million and 3 million, right? If that doesn't do it, then you know it's the other half, and you just narrow it down. And it took me an hour and a half to 2 hours to do that with a NetBSD exploit. Except I was lucky there where it didn't happen at 3 million packets, it happened at 30,000 something. So that's how you do that. That's an excellent question. You get a t-shirt. There we go. Anybody else? Mr. Bauckham, would you like to come up and...
How many intrusion detection systems did you test?
How many? He said, how many intrusion detection systems did you test? With Whisker? With all these tools? Well, I tested 5. Professionally or in my spare time? Huh? Together? 7. I really don't want to, I would rather not advocate anything. I don't work for a vendor anymore, by the way. As I'm sure you will all find out, you get burnt out on this crap after a while, and you just don't want to deal with it anymore. That's why I'm doing this, is so people can test this stuff themselves, so admins can go, if a vendor says, it detects everything under the planet, and then you can test for yourself, and if you really feel like it, you can post a bug track and get your 255 TTLs of fame. So that's part of the reason for this talk. I wanted to do this, is to enable people to do this themselves. Yes? Yes.